Hello everyone, I'm Dr. Amita Kapoor. Many people ask me, Amita, I want to start my journey in AI, but do I need to go out and buy a $3,000 laptop with a powerful graphics card? My answer is always a firm no. In fact, that is the biggest barrier I want to break down for you today. Whether you are a student, a researcher, or a professional looking to pivot, the most important tool in your kit is actually free, and it lives right in your web browser. It is called Google Collaboratory, or Colab for short. You can think of Colab as your gateway. In the professional world of artificial intelligence, we don't just write code, we experiment. We need massive computing power to train models, which normally costs a lot of money in electricity and hardware. Colab is Google's way of democratizing that power. They are essentially lending you a high-performance computer in the cloud for free. And this is why anyone starting in AI must master this ecosystem first. It removes the financial paywall and lets you focus purely on the science and the logic. Now a quick reality check. Colab is incredibly generous, but it is a shared infrastructure. That means your session can disconnect if you are inactive. GPUs are not guaranteed every time, and very long training jobs can be stopped. This is not a flaw, it is how professionals learn to design efficient experiments instead of wasting compute. Let us now open the hood and see how it exactly works. When you go to a Colab link, you see a notebook. A notebook is a document that contains cells. Now, if you have never used one, think of it like a smart piece of paper. You have text cells where you write your notes and code cells where you write instructions for the computer. Because I've spent years educating global audiences on AI, I can tell you that the secret to learning is this: interactively. You write a little, you run a little, and you see the result immediately. Let us try a first principle exercise. In a code cell, type 5 plus 5 and hit that little play button on the left. Now look closely. For a split second, you will see a connecting status at the top right. In that moment, Google is assigning a dedicated slice of server just for you. It does the math and sends the number 10 back. You just performed a cloud compute task. No setup, no configuration, just instant results. This is the zero friction environment that makes AI development possible for everyone. One important thing to know early is this: computers are deterministic, but AI experiments often are not. Many AI operations involve randomness, and that is why you might run the same notebook twice and see slightly different results. Later, I will show you how professionals control this using something called as a random seed, so experiments can be reproduced. Now, let us look at how we handle information. In the world of AI and data science, we deal with tables, lots of them. We call these data frames. Usually looking at data in a computer program is like reading a long, boring text file, but Colab makes it visual. I'm going to run a few lines of code here to create a simple list of AI concepts and their difficulty level. Notice how it looks like a clean, organized table. This is the Pandas library at work, which is one of the industry standard for data handling. But here is the magic part of Colab ecosystem. Normally, if you wanted to search or sort this table, you would have to write more complex code. But Colab has a built-in feature called interactive tables. By adding just one special command, our static table transforms. Suddenly, you have search bars and filters right there in your notebook. It turns your data into an app. For a beginner, this is a game changer because you can feel the data and explore it visually without getting lost in the syntax. Now we have started slow because I want you to feel confident. You now know that you don't need a $3,000 computer to do AI. You just need a browser and a Google account. You have learned how to run a cloud cell and how to view data interactively. This is the foundation of every AI system I've ever built. Next, we are going to look at the invisible computer that Google gives you, the Linux system, and how to save your work so you never lose progress. Now, the computer that Google gives you is ephemeral. That is the fancy way of saying it is temporary. When you close your browser tab or stay inactive for too long, about 45 minutes, Google takes that computer back and wipes it clean to give it to the next person. And it is not just your files that disappear. Any libraries you install or system changes you make are also wiped out. And this is why professionals always keep a small setup cell at the top of every notebook, so the environment can be rebuilt in seconds when Colab resets. I'm going to show you how to master this invisible computer and how to link it to your Google Drive so your work is saved forever. So, what exactly is this invisible computer? It is a virtual machine, or VM for short, running a professional operating system called Ubuntu. In the world of AI, Ubuntu is the language of pros. Even though you see a friendly web page, there is a full-scale server underneath. To truly master AI, you have to be comfortable talking to the machine. In Colab, we do this using the exclamation mark trick. Let us try it. If you type exclamation mark LSB underscore release space -a in a code cell, you're asking the computer, hey, who are you? When you run it, you will see it is running Ubuntu 22.04. This is the same system used by engineers at the top AI labs. We can also check our brain capacity. Just type exclamation mark df space -h to see how much disk space Google gave you, usually over 100 gigabytes. It's a massive playground. But remember, once you disconnect, this playground is reset. This brings us to the most important step for any beginner, mounting your Google Drive. Think of Colab as a rental car. You can drive it fast, but you don't want to leave your luggage in the trunk when you return it. Google Drive is your personal garage, where you keep your luggage. By mounting Drive, we create a secure bridge between the temporary Colab computer and your permanent storage. This is how you keep your datasets and AI models safe. One important responsibility comes with this power. Never upload confidential, personal, or restricted data to Colab unless you are explicitly allowed to. Cloud tools are powerful, but professional AI work always respects privacy, ethics, and data governance. Now, to do this, you can click the folder icon on the left sidebar and then click the Mount Drive button. Colab will ask you for your permissions to see your files. Once you say yes, a new folder appears called Drive. Now, anything you save inside content/drive/my drive will stay there forever, even after the Colab computer disappears. This is the golden rule of Colab. Always work inside your Drive folder if you want to save your progress. But here is a pro tip. Reading thousands of small files like photos for an AI to learn directly from Google Drive can be slow because it has to travel across the internet. You can think of it like trying to read a book page by page by calling someone to read it to you over phone. It is better to copy and unzip. So we keep our data as one big zip file on Drive, copy it to the local Colab disk and unzip it there. This makes your AI training up to 50 times faster. Up until now, we have been using a standard CPU, a central processing unit, to run our code. It is great for basic math, but if you want to teach a computer to see images or understand language, a CPU is like trying to clear a snowy highway with a hand shovel. Let me show you how to trade that shovel for a fleet of snow plows. We are going to unlock the GPU and the TPU, the specialized chips that make modern AI possible. Let us start with why do we need a GPU? AI is built on matrix multiplication, essentially doing millions of tiny math problems at exact same time. A CPU is brilliant, but it handles tasks one by one. An NVIDIA GPU, like the T4 available in Colab, has thousands of cores that work in parallel. It is the difference between one person solving a puzzle and 1,000 people each putting in one piece at the same time. And this is why AI research has exploded in the last decade. We finally have the hardware to keep up with our ideas. In Colab, getting a GPU is a zero-cost upgrade. You go to the Runtime menu, select Change Runtime Type, and choose a T4 GPU. Instantly, Google connects to a $2,000 graphics card to your notebook. If you are a pro user, you might even get access to A100 or H100, a beast of chips that can be almost 7 times faster than the standard T4. This democratization of hardware is the single most important thing for anyone starting in AI today. One subtle but important point: a GPU doesn't make everything faster. It only helps when your code is written to use it, typically during neural network training or large matrix operations. For everyday tasks like data cleaning or simple logic, the CPU is often faster. Knowing when to switch tools is a key professional skill. Once the GPU is connected, we need to make sure the computer sees it. We use a professional command called !NVIDIA-SMI. This gives us a dashboard showing our GPU's health, its memory, and how hard it is working. Think of this as your car's dashboard. If you see 16 GB of VRAM, that is your fuel tank for data. If you try to load a model that is too big for that tank, you will get an out-of-memory error. Understanding this dashboard is the mark of a real AI developer. But what if you're building something truly massive? That is where the TPU comes in, the Tensor Processing Unit. Unlike GPUs, which were originally made for video games, TPUs were designed by Google specifically for AI from the ground up. They use something called as systolic array to move data like a heartbeat. While they are incredibly fast, they require special code to work. For most of you starting out, the GPU is your best friend, but it is good to know that the TPU rocket ship is waiting for you when you are ready. Here is a common mistake: thinking the GPU makes everything faster. If you are just adding numbers or cleaning a small CSV file, moving that data to the GPU actually takes more time than just doing it on CPU. Only use the GPU when you are training a neural network or doing massive matrix math. Use the right tool for the right job. As you grow in AI, you will learn exactly when to flip the switch to high performance mode. And remember this: more compute doesn't make ideas smarter. It simply lets you test ideas faster. The quality of your thinking will always matter more than the power of your hardware. So now you have the engine, the garage, and the cockpit. But what if you are staring at a blank screen and don't know the first line of code to write? In 2025, Google transformed Colab into an AI-first platform by integrating Gemini directly into your notebook. Now, I will show you how to use this AI assistant to write code, fix your mistakes, debug the program, and even act as a data science agent that does the heavy lifting for you. The most powerful thing about Gemini in Colab is that it is context aware. It doesn't just know Python, it knows your Python. It looks at the variables you have defined, the data you have loaded, and the libraries you are using. If you type a comment like #plot a bar chart of student grades, Gemini doesn't give you a generic example, it generates the exact code using your specific column names. It is like having a coding partner who has already read your entire project. But here is an important mindset shift. Gemini is powerful, but it is not an oracle. Treat it like a very fast junior assistant. It helps with boilerplate, but you are still responsible for understanding and verifying the code. Silent bugs are far more dangerous than visible errors. Now, we all face errors even after years of teaching. At Oxford, I still run into bugs. Usually an error message is a scary wall of red text, but in Colab, you will see a button that says explain error. When you click it, Gemini analyzes the stack trace. That is the computer way of saying, here is where I got confused, and tells you exactly how to fix it in plain English. It drastically reduces the mean time to recovery, which is a fancy way of saying you spend less time frustrated and more time building. But we can go even further with the data science agent. You can think of it as an autonomous assistant. You can give it a high-level goal, like clean the data set, find the average age, tell me if it correlates with the salary, or build a model to predict this particular column. The agent doesn't just write the code, it creates a plan, executes the steps, checks for errors, and self-corrects if something goes wrong. It is moving us from coding to orchestrating. For those of you taking your first steps, remember, AI is not here to replace your thinking, it is here to handle the boilerplate, the boring, repetitive parts of coding. This allows you to focus on the why and the what, and as you use Gemini, pay attention to the code it writes. It is a fantastic way to learn new Python tricks and best practices while you work on your own ideas. Okay, now we have spent a lot of time working directly in cells, and while cells are fantastic for seeing immediate results and teaching concepts, they are not how we build professional production grade AI. In the real world, the kind of work I do with different organizations, we don't deliver a notebook, we deliver a structured project made of .py Python files. So now I'm going to show you how to transition from a student using cells to an engineer building a multi-file project right inside the Colab. To do this, we need to master magic commands. These are special instructions that start with a % sign or a double % sign. One of the most important is % write file. When you put this at the top of a cell, Colab doesn't run the code in the notebook. It saves that code into a file on the virtual machine's disk. This allows you to build a library of scripts that you can reuse, import, and eventually deploy. Once you have written your file, how do you run it like a professional engineer? You use the exclamation mark again with Python command. By typing !python myscript.py, you're telling the underlying Ubuntu computer to execute your file just like you would on a local server. Remember, the notebook is for exploration, but the script is for execution. Colab even gives you a built-in file editor. If you double-click any .py file in the sidebar, a text editor opens right inside your browser, just like VS Code or Notepad++. You can write your helper, functions, and utility scripts here, keeping your main notebook clean and organized. The split view is where the magic happens. You write your logic in the script on the right and you test it in the notebook on the left. Finally, let us talk about shell magics like %cd. When you move into production, your projects will have folders for data, models, and scripts. In a normal notebook, if you change a directory using !cd, it only lasts for that one cell. But if you use %cd, it changes the directory for the entire session. Mastering these small differences is what separates a beginner from a professional who can navigate a complex AI file system with ease. You are now ready to build real-world AI applications. You have learned to use cells for discovery and scripts for production. You can navigate the system, manage your files, and prepare your code for the outside world. This concludes our deep dive into Google Colab ecosystem. You have the tools, the hardware and the mindset? Now I want to see you put it into practice.